So we've done a lot of stuff, and it's time to summarize and take stock. We've looked twice at existence and equivalence and different representation theorems. And now let's talk about what they mean and why they're useful. Here's sort of a schematic of what we've done. We've looked at asset pricing in a couple of different ways. Prices expected discounted payoff, expected returns or linear and betas, or something's on the mean variance frontier. We've looked at continuous time representations or discrete time representations, and we translated discounted payoff into a set of risk-neutral probabilities. And you've learned how to go from each of these to the others. Given any of these representations, you know how to construct one of the other representations. You understand they're completely equivalent. We did some existence, too. The law of one price means there's some discount factor, or no arbitrage means there's a strictly positive discount factor. That's similar to, in order to construct a mean variance frontier, you need a non-singular covariance matrix so that you can invert it. That's the same thing, really, as the law of one price. So the existence theorems and the representation theorems just connect all these many different ways of looking at asset pricing and tells you what it takes for any of them to make any sense. What do you learn from all that? I think there's two big lessons. First, price equals expected discounted payoff, or any of these representations, by themselves don't tell you that much. They exist if there's just no arbitrage opportunities, which is a very weak condition. If you want to test asset pricing models, if you want asset pricing models that are going to work out a sample in particular, connecting the discount factor or the risk-neutral probabilities and so forth to data, figuring out what the factors are, that is where all the meat of an asset pricing model is. Second, since we have so many different representations, use the representation that works best for the application you have. Finance is not a deep theory field. It's a practical application field. And each of these has its adherents because each of these tends to make life simple in certain applications, but know how to translate them. It can provide a lot of insight if you're doing risk-neutral probabilities to understand that really that's the same thing as the statement of something's on the mean variance frontier.